Okay. We'll be taking a look at LeetCode's weekly contest 480. Okay, so let's see the first question. Absolute difference between maximum and minimum k elements. So we are given an integer array nums and an integer k. We need to find the absolute difference between the sum of the k largest elements and the sum of the k smallest elements in the array. Return an integer denoting its difference. So there are two approaches for this. So basically for each value, we need to make sure if it's among the k smallest elements, that value will not be contributing towards the final answer. That means it will subtract from a final answer. And if it's towards the k largest ones, if it's among the k largest ones, then it will contribute to our final answer. So all we need to do is just sort the array and then iterate through the first element first. Yes. So we just need to go through the first elements and then add them, then subtract them from our sum. We just need to go through the first k elements and add them to our sum, and then we need to go through the last k elements and then add them to our sum. So let's take a look. Let's just see that on an example. So for example is 5 2 2 4. So 5 2 2 4, and after we sort this we will get 2 2 4 and 5. So if our k is 1, for example, then we need to look at the k smallest elements, that means the one smallest element, and we need to look at our k largest elements, which is 5. So we need to find the difference between them. So clearly, obviously taking the sum of our largest elements will be strictly greater than or equal to taking the sum of the k smallest elements. So let's go through the k largest ones and we'll keep a track of sum, and we'll add each of these values to our sum. So while I'm iterating from behind, for k for 1 I'll add 5, I'll do sum plus equals 5. Then if k was 2, I would do sum plus equals 4, and then my final sum would be 9. Then I need to remove the k smallest elements from my list. So I will remove, so then I will start iterating from in front, and I'll encounter 2. I will do sum minus equals 2, and then I'll come to the next one and again do sum minus equals 2. So finally my answer will be 5 plus 4 minus 2 minus 2 for k equals 2. Let's take a look at how to code this out. So I'm given my input vector nums. How about I zoom in? Let's do this. Okay, let's paste this in here. Okay, so I'm given my input vector nums. So let's first begin by sorting nums. So I sort nums. Then let's keep track of my sum called sum. Now I will iterate through the first k elements in sum. Let's also keep track of the size of our array, which will be size n equals nums.size. So now so the first k elements will be the smallest ones after sorting. So they will subtract from our sum. So sum minus equals nums I. And now we want to go through our k largest ones. So again, and then add them to our sum. So let's again iterate through, I think, k times. But this time we want to add to our sum, and we want to index into the k last ones. So for I equals 0, so if my indices are 0 1 2 2, 3, and 4, and I want to take k equals 2. So if I want to iterate through this backwards, for I equals 0, I want to map this to the number 4. For I equals 1, I want to map this to the index 3. So I can do this by taking n. In this case, n is equal to 5. N minus 1 minus I to find the corresponding index. So let's do n minus 1 minus I. And we add them. And finally, sum should have the required answer. So we just return sum. Let's take a look at how this. Oops. Okay, let's run it on the samples. It's passing the samples. And let's submit it and check. So yes, this idea works. So to recap, we just sort our array, and then we just iterate through the k smallest elements, and they will subtract from our sum. And we iterate through the k largest ones from behind, and they will add to our sum, because we need to find the difference. Now let's take a look at the next question. Okay, reverse words with the same vowel count. We are given a string S consisting of lowercase English words, and each is separated by a single space. Determine how many vowels occur in the first word, and then reverse each of the following words that has the same vowel count. Leave the remaining words unchanged. Okay, so over here we need to do two things. So first we'll be given a string. Let's say of the format cat, dog, eat. So we need to first split our given input string into all of its components. So and each component is separated by a space. So we find each of the spaces and we split our string into smaller strings based on that. So this will become cat, dog, and eat. Now we need to count how many vowels are there in the first one. So we just need to iterate through our string, and if we ever encounter a character which is equal to one of the vowels, that is A, E, I, O, U, if we find one of these, we will increment our counter. And then we need to go through all of the remaining strings and then check for them whether their vowel count equals the vowel count of my first one. So I will compare these two, then I will compare these two, and so on. So we just need to define a simple function which will check for a given string how many vowels are there in it. And then we also need to split our string. And then once we do that, all matching strings need to be reversed. If the vowel count matches the first one, we reverse them. And then we just reconstruct our final string by joining all of these elements back with a space in between them. So let's see how to code that out. Okay, so we are given a string S. So first let's define our helper function which for a given string will calculate how many vowels are present in it. So let's call this int count vowels. It will return an integer. We can take the string by reference. Okay. Now we just iterate through it. Let's keep a counter which will initially start at 0. And for every character in my string, if the character equals either A, or the character equals E, or the character equals U, or equals I, or if it equals O. Or, yes, in this case, we just increment our counter and we finally return it. So this will take, for each character, we are only performing 5 checks. So this will be order of n, and n is the length of the input string for this function. So this function will correctly count how many vowels are there in each character. Now we need to split our string. So let's split in my vector will be the one I need to keep track of. So when I encounter C, I will add C to the string. Then I encounter A and then T, so on. I will add A and T to my vector. But when I encounter the space, I will start a fresh string. So when I encounter this space, I will push back a new string into this. So then the new characters will all go into my, because each time I will add the characters to the last string in my vector. So then the new characters will go to the second string, dog, and then again there's a space which will introduce a new string for eat, and so on. So let's code that out. So initially I start off with an empty string, and then I'll iterate through all the characters in my input string. So if the character is a space, then I need to append a new string at the end of my current vector, because now a fresh string is going to start up. And otherwise I can just do dot back, basically accessing the last string in my vector, and I push that current character into the back of that thing. Each of these operations takes order of 1, because over here we are appending to a vector, and over here we are appending a character to a string. Both of these take constant time, so the overall time complexity of this for loop will be order of n, where n is the size of this input string. Now we need to count the number of vowels in my first string. So for that I can just do counter, let's call it first count, and to that I will call count vowels, and I'll pass in my first string, which will be at the index 0. Then I'm going to iterate through all of my other strings starting from index 1. So let's keep a track of how many strings I have. vs.size will give me the number of strings I have, and then I want to go till I less than n. Okay. So now basically when should I reverse the current string? My current string will be vs of I. So I reverse it only if count vowels of vsi equals first count, if it equals the count of the number of vowels in the first string. So if this is true, then I want to reverse the whole string. So then I can just do a reverse vsi.begin dot end, and this reverse function works in order of n. So for the length of, so it will take as long as the length of the string vs of I. So this is correct. Now all of our strings, the strings which have to be reversed, have been reversed. So now we need to rebuild our final answer. So to rebuild our final answer, I will take a string. Let's say I start off with my answer string, and it will be empty to begin with. Then I will go through my vector, and I will keep on appending each new string that I find. And each new string I find, first I'll append the current string. So I'll do answer plus equals s. And then because I need to maintain a spacing of one space between all of the strings, I will do answer dot push back. I'll push back a space into it. So now finally, after the last string is processed, my answer will have one extra space at the end. So all I need to do is just remove that space. So let's see how to code that out. So first I'll have my string ans. Now for every new string in vs, For every string in VS, I'll just do ans plus equals s. And I also need to append an empty, basically a space at the end of each string. And then finally my ans will be left with one extra space at the end. So all you need to do is ans.pop back and return it. Let's see whether this works. Yes, it seems to pass all the samples. Let's submit it. Yes, it passes. So basically all we had to do was just split our input string into all of its substrings, and then for each substring just perform a normal vowel check and count the number of vowels. So this whole thing should take order of n, because each character is processed a constant number of times, and we will have n characters. So the overall time complexity is big O of n. Okay, now let's take a look at the next question. Okay. Minimum moves to balance a circular array. We are given a circular array called balance of length n, where balance I is the net balance of person I. In one move, a person can transfer exactly 1 unit of balance to either their left or their right neighbor. Return the minimum number of moves required so that every person has a non-negative balance. If it is impossible, return -1. And we are guaranteed that at most one person has a negative balance initially. So basically we are given a circular array. So it could be like 5, 4, -5, 2 and 1. Okay. So the question says there will be at most one person with a negative value. And our goal is to make sure that no one has a negative value, a negative balance at the end. The minimum number of moves required so that every person has a non-negative balance. Non-negative means greater than or equal to 0. And at most one person will have negative balance. So first we just go through our whole array and check whether there is any negative value. If there is no negative value, our answer is just simply 0. We just said it, our answer will be 0. Now we need to find whether there is one negative person, and there will be at most one. So if our answer is not 0 initially, then there will be some index such that there is a negative person over here. Okay. Now for that negative person, the other people can contribute to this person from the left and from the right. And in one move, each person can move 1 unit of balance either to the left or to the right. So basically all of the neighbors of our negative index will help out from this side or this side. And because we want to calculate the minimum number of moves required, we will take help along the shortest path. Basically, this element will not contribute clockwise, because shortest path to our negative element is counterclockwise. For this index too, this index will contribute clockwise and not counterclockwise because this length is smaller. This index will contribute counterclockwise and this index will contribute clockwise. So basically we just need to find for each index what is the shortest path to my negative index. So either like this or like this. So let's say we find the path cost from in one direction, it's d1 and d2. So basically the circular distance of this index will be the minimum of clockwise direction, which is CW, and the counterclockwise direction. This is your distance between two people in a circular array. Now to move 1 unit for this person to contribute 1 unit to a negative person, it will cost 1. Per unit, that unit has to travel only 1 step clockwise. So in one move, 2 will become 1 and 5 will become -4 in 1 step. And then in another step, this can become 0 and this will become -3. So if your distance from your negative value is 1, for each unit that you contribute, these two are at a distance of 1, so to contribute 1 unit, per unit cost is equal to your distance, let's call this d, will be your distance from the person, so per unit cost. So as you can see, if you are 2 units away, if you're over here and you want to contribute to 5, -5 over here, in one move you can make yourself 0 and make this 3, and then it will take a second move for your contribution to finally reach the negative position. So the per unit cost becomes d, which is the closest distance, because you could also contribute counterclockwise, but then that would just increase your per unit cost. So now all we need to do is, for each index that is non-negative, we need to sort them based on their distance from my negative index, because the ones which are further away will have more cost per unit and the ones which are closer will be cheaper. And then we just keep on seeing, okay, how much can each person contribute. So for example, in this case, this index 4 is at a distance of 1. 2 is at a distance of 1. Let's say this is the 1. This 1 is at a distance of 2. And 5 is at a distance of 2, because 5 at distance of 2. Over here it's a distance of 3, so we take the minimum path. So 2, and 1 has a minimum path from here, which is a distance of 2. So while I want to make my -4 become non-negative. So for -4, I will see how much can this person contribute. This person can contribute at most 4, because if this person contributes more than 4, if they contribute 5, this person will become -1. So a person can contribute an amount equal to their value, at most an amount equal to their value. So in this case, the first person itself is enough to contribute everything. So this person can donate 4 and this will become 0. And this person, because he donated 4, he will also become 0. But now what if the value required was more than that? What if this was, let's say, -5? Then from the first person we'll see, okay, how much can you contribute? You can contribute at most 4. You can contribute up to 4. And do I need at least 4? Yes, because right now I'm at -5. The negative value is at -5. So a complete contribution of 4 is useful. So we will take 4 from the first element at a cost of 1. So 4 into a cost of 1 per unit. So now after this contribution, my final sum will be -1. So I now move on to the next person. And if you notice, these people are sorted based on their per unit cost, because I want to take the cheapest units available I have first, and then I'll move on to using up things which will take a longer path to reach me. So now we need at most 1. So basically from here I need a contribution of 1. The remaining contribution I need is 1. So this can contribute at most 2. So I'll take the minimum of what you can provide, which is 2, and what I actually require. From here I require 1 more, and that will give me 1. So I'll take a contribution of 1. So finally I'll take a contribution of 1 into the per unit cost is still 1. So this is the amount it will take. This is the minimum number of moves required to make my negative number 0. So the answer for this would be 5. But now what if this was a -7 instead? Then again, let's see how this would run. I would take my maximum, I would take min. So currently it's -7. My sum is -7. My current negative value is at -7. So minimum of what my first person can contribute, which is 4, comma 7 is what is required. So I will take 4 from the first person. Now the first person is used up completely. So let's say he will take 4 into per unit cost was 1. Next, now my new sum after taking 4 from the first person is -3. So now let's see for the second person. I'll take min of 2 because the second person can contribute at most 2, comma the required amount. I still require 3 and the minimum of this is 2. So from the second person I will take up to 2 elements. I will take 2 elements. So 2, I get 2 at a cost of 1 per unit because here's the cost and here's the maximum amount this person can contribute. Now finally, now after taking the contribution of 2, my final sum is -1. Now I can take a contribution of 1 from this person because min of 1 comma 1 gives me 1. So from the last person I'll take a contribution of 1. But this time you need to be careful that the cost per unit is 2 over here. So it will be 1 into 2. And finally, after taking this contribution, my final sum is 0, which means now everything is non-negative. So as you can see, if this number were -12, then all the contribution would get used up. But if it's -13, then no matter what the others do, the others can contribute a sum of only 12. 9 plus 1, 10 and 12. So even after everyone contributes and everyone else becomes 0, after everyone else becomes 0, this index will still be at -1. So it's not possible to make this index non-negative. So after everyone has done the contribution, if your index is still lesser than 0, in that case our answer will be -1. And if not, our answer will be the sum of all the contribution times the cost per contribution. Okay, let's see how to code this out. Okay, so our final answer can be in long, can go up to long. Okay, and we're given the balance. Let's shorten this variable name. Let's call it b. Let's call it bal. Okay, so now we want to find out whether there is at least one negative value first, because if there is no negative value, our answer is directly 0. So first, okay, let's say neg will be the index, call this neg index. So initially let's set it as -1 because -1 is not a valid index for any array. So, and let's also keep track of the size of our array. Bal.size. Okay, now for every value in this, if the value is negative, if bal I is lesser than 0, if it's lesser than 0, then I will set my negative index equals to I. So if there is at least one position, my negative index will no longer remain -1. So I can check. So if neg index is still -1 after you go through your whole array, that means there was clearly no value which was lesser than 0. So our answer is directly 0. We can return 0. Okay. But if this was not the case, then we need to see how much each person will contribute to my answer. Like how much can each person contribute and what is their per unit cost. So how much can they contribute and what is the per contribution cost. So, and to recap, the per unit cost is the distance of the shortest path, the minimum of clockwise distance and counterclockwise distance to my negative index. So let's see. for int I equals 0, I less than n, I plus plus. Okay, so let's keep a vector of pairs. So let's call it contribution. So contribution is going to store, this will store the first value in, like, it'll store a bunch of pairs, and each pair represents one person who can contribute to my negative person. So the first value will be the per unit cost, and the second value will be amount they can contribute. So basically this will be minimum of counterclockwise and clockwise, and this will be just their value, their bal of I. So first, okay, we don't want to, the negative person will not contribute to himself, so we'll just first skip over their index, I equals neg, and we just continue if that's the case. Now we need to calculate the minimum path. So let's see how to do that. So if you're in a circle, or let's say you have is actually given to us as a vector, a 2D array which is circular. Okay, so if you are at position I, this is I, and this is my negative index. Now I want to find the minimum circular path. So I've got two ways to reach neg. One is I could go forwards like this, or one is I could go backwards. Now the length of this path is the same as negative going forwards and reaching I. So one of them will move forwards. So either the path length will be the distance taken by I to reach neg if I moves forwards, or the distance taken by neg to reach I if neg moves forwards. So the distance taken by I to reach my index, let's call it j, to reach j will just be j minus I. These many moves will be taken. And the distance for j to reach I will just be n minus j plus I. Now let's see why this works. So for this array, my n equals 6, I equals 0. How about let's make I equals 1 and j equals 4, because this is 0 based index. Okay, so now n minus j will tell me how many steps do I need to reach the first index. So n minus j equals 2. So that shows one jump to reach the last position and one jump to reach the first position. And then I just need to jump these many steps to reach I. And because I is 1, I need to jump one extra step. So if I was 0, just after moving n minus j steps, I would have reached I. So a plus 0 would not have changed my answer. But because I is at plus 1, the index of I is 1, I need to move one extra step to reach I from the first position. So n minus j plus I. Now if you notice, this works only if j is greater than I. So if I is ahead of j, basically if j was here and I was here, the roles would just swap. So basically it would be minimum of I minus j, which would be for j to move forwards, and n minus I plus j, which would be for I to move from behind and come in front. Let's code that out. So case 1, if I is lesser than neg. So neg is basically my j. So if I is lesser than neg, then we take a look at our first case over here. These two. So if I is lesser than neg, so my per unit cost, let's call it PUC, per unit cost, will be equal to the distance, the clockwise versus anti-clockwise distance. So that will be minimum of negative minus I and n minus negative plus I, the minimum of these two. And finally, so now I need to let's declare PUC outside, and I'll set the value inside over here. And if I is not lesser than neg, I will never be equal to this value because we are going to skip over it. Okay, I wrote. Okay. No, sorry. It should be negative index. Yes. Now the other case. This is the case where the negative index is lesser than I. So in this case, we just swap the values. It will be I minus the negative index and n minus I plus negative index. Okay. And finally, for each person, we need to push back the per unit cost and the amount they can contribute. So contrib dot pushback. So per unit cost is my PUC, and the amount that they can contribute will be BI. Bal of I in a pair, and yes. So now I want to sort them based on the lowest per unit cost first. So by default, sorting a vector of pairs will sort based on the first element first and then the second one, and that is optimal for us. So we just need to call sort on contrib.begin.end. Now that they are sorted, we just need to iterate through all of these and calculate our answer. Initially, our answer will be 0. So for every PUC, comma, amount that they can contribute, let's say the amount they can contribute is B. In my vector of pairs, PUC will, the first value of the pair will be put in PUC and the second value will be put in B. So how much do we want to take from this current person? This current person, the amount we take will be the minimum of what I still need. The amount I need will be the negative, if B of negative index equals minus 5, then the amount I need is 5. So I will take minus of B of negative index and compare this with the minimum that my current person can contribute. This will be balance, sorry. Yes. And compare this with the amount that they can contribute. So the amount we will take from this person will be the minimum of these two. Now basically our answer will get updated to reflect the following. The amount we are taking times the per unit cost times the PUC. Because for every unit that we took, we multiplied with the cost. And then finally, our value at the negative index will increase by the amount that we took. So, okay, now one thing to note over here, this could lead to an overflow, because if the amount we're taking is like around 10 raised to the 5 and PUC is also like pretty large, then this will exceed the capacity of a normal 32-bit integer. So we typecast one of them to long. And yes, okay, so this works. Now let's take a look at the last question. Minimum deletions to make an alternating substring. So we are given a string S of length n consisting of only characters A and B. You're also given a 2D integer array queries of length q, where each query is of type 1 or type 2. So type 1 gives us a single index j, and we have to flip the character at index j from A between A or B. And we're given a query of type 2, which gives us a range L2R, and we have to compute the minimum number of character deletions required to make a substring L2R alternating. And this operation does not modify it, we just need to find the value for that, the answer, if we were going to perform it for that given substring. So let's see what this would mean for us. Okay, so given a string, let's say consisting of only A, B, A, and if we want to make it completely alternating, we care about all the positions, any position which is equal to its previous value. If like A is equal to the previous value, this kind of position will have to be deleted, because if we want all alternating, we want A, B, A, B. So any extra A's that come over here have to be removed, and any extra B's that came over here have to be removed. Any A's that came over here have to be removed, and any B's that came over here have to be removed. So basically, we want to we want to remove any character which is equal to its previous one. So, and when we get a query update, so that is to handle queries of type 2, where I'm given a range. So for a given range, I will need to answer how many values in this array are equal to their previous position. And when I'm given a flip command, query of type 1, in that case, I just take a certain element, and let's say this was initially A, and I flip it, it will become B now. So it is no longer equal to its previous one, but the one after it might now become equal to it. So we just need to keep a track of. So a flip command will affect the current value, because it now might not be equal to the previous one, or it might now be equal to the previous one, and it will also affect the value that comes after it, because that value might again change, whether it's equal to the previous one or it's not equal to the previous one. So basically my idea is, if for each value, if it's equal to the previous one, we will mark it as a 1, and if it's not equal to the previous one, we'll mark it as 0. So initially my A has no previous one, so it's going to be 0. B is also not equal to the previous one, it's going to be 0. But this B is equal to the previous element, so I'm going to mark it as 1. This A is not equal to the previous element, so it'll be a 0, but this A is equal to the previous element, I'll mark it as 1. So now if you notice, if I want to answer a query for some range, I just need to take a look at that whole range. For example, in this range, if I wanted to answer how many operations will it take to make this whole array completely alternating, for that I just need to remove all positions which have a 1 over here. So for over here, my answer would be 0, because there is no position with a 1. For this range, my answer will be 2, because there are 2 such indices which need to be removed. And after we remove all of these indices, I'll be left with an array which is completely alternating, because if I take this position B, because it's a 0, I don't want to remove it, but all positions with the 1 have to be removed. So I will remove this one, this gets skipped. This is 0, I will take this element, I get an A, and this position over here is a 1, it'll get skipped. So finally I'm left with a completely alternating string. But now what if I had to answer for how many moves will it take to make this string alternating? Now I might end up seeing 1, a cost of 1, so I remove this. I take this A, and then I see another cost of 1, so I remove this, which would mean 2 have been removed, which is incorrect because I can just remove one index over here and remove. So basically, if my first value is a 1, the 1 means it is equal to the previous value, but because it's not in my current range, I don't really care about this specific value. So I will, to actually answer the number of moves required for my current range from L to R, I will actually query the number of ones in the range L plus 1 to R. So I just need to query this much over here. Because if the first, so let's say, in my given array, if the first position is 1, that means this index is equal to the previous one. But the previous one is not in my range that I care about. So I want to skip this. And if it was 0 anyways, then starting from L plus 1 will not change my answer, because my answer needs to be the sum of ones in my range. So always querying L plus 1 to R will give the correct answer. Okay, so now we want a data structure which will efficiently allow us to update the value at a certain point and also query the sum of a range. So segment trees are very convenient to perform this kind of an operation. So the way a segment tree works is, let's say I've got an array of size 8. Then let's say it's got a value of, let's say 1 0 0 1 0 1 1 0. So the way I'll build a segment tree on top of it is, I'll take these two nodes, I'll create a fresh node for it. For every 2 nodes, I'll create a fresh node on top of it. And then again over here for these 2 nodes. And then finally, this will be the structure for a segment tree on top of this array. And because at each step, the number of nodes is halving. Initially, I had 8 nodes. Then I've got 4 nodes, 2 nodes, and 1 node over here. The height of the tree will be log n. Log of n. So now what are we storing in each node? In each node, I'm going to store the sum of its respective range. So this node handles this whole range. So it will store a value of 1. This node handles this whole range. It will store a value of 1. Let's say this value is 0 and this value is a 1. This node handles this whole range, and the whole sum in this is 0. I take 0. And this node handles this whole range. So I put a value of 2. Basically, each node just needs to take the sum of the 2 nodes right underneath it to get its answer. Now let's make this a bit bigger. So this node represents this whole range over here. And to get the correct sum, it just needs to take the sum of these 2 nodes. Answer will be 2. And this node again needs to care about this, represents this whole range. This node represents this whole range. And its answer will be the sum of the 2 nodes right underneath it, which will be 2. And finally, my overall range will care about the whole array, and the answer is 4. So if you notice, this correctly answers for, like, this node represents the whole array, and in the whole array we see there are 4 ones over here. In this node cares about this much, and in this section we see that there are 2 ones over here. So basically, when we update a specific node, if a value changes from 0 to 1 or from 1 to 0, we will come down, we will find that node, and And the value changing in this node will not affect anything over here. This will not be affected. And this value will not affect any changes over here also. It only affects changes on the path leading to it from the root. It'll only change on, only these values will change. And because the height is log n, each time we make a change, only log n nodes need to be updated. So we can answer query of type 1, the flip query. We can do it in log n because it will change only log n nodes. Okay, now we need to handle our range queries. Now each range can be split into smaller sub ranges. So for example, if I wanted to query this range, now we might be tempted to go down this range and check each position over here in the range, but that will take order of length of the range, which will take too long, because we will be given roughly n queries, q queries, and if each length is of size n, that will take q into n, which is greater than 10 raised to the 8, which is too many operations to be run in roughly 1 second. So we want to keep it logarithmic. So using the properties of a sectary, any given range can be split into log n number of sub ranges, which will be covered by our sectary. So for example, this node. Okay, so for each node we will see whether it lies within my given range or it does not. So number 4, the topmost node represents this whole array, which is going to overcount these positions over here. So we don't want this node. How about we increase our array to here, this much? Yes. So now we will say that, okay, this range is counting too much. So let's move to this sub ranges. We will now see whether it can be computed using this plus this. Now for this node over here, we'll see that, okay, it represents this whole array, this segment, which is still more than our range. It's going out of bounds for our range. So we'll again move this down over here. This one is completely out of bounds for our range. We don't care about this answer. This node now, it lies completely within my range. So this node will contribute to my final answer. Now this node, do we need to move this node down? This node handles this whole range, and that whole range does overlap with my query range. This range is a subset of my query range. So rather than having to move down from this node, I can just take this topmost answer directly. And this will mean that this will also take log n number of steps, because each node, if there are a bunch of nodes consecutively, they will get handled by some parent high up. So we don't need to go all the way down and check each node individually. So now basically the whole question was about making a segment tree and keeping track of 0 and 1 and the sum along every range. So now let's see how to code this out. Okay, so we need to make a segment tree which supports a range query and a point update. So in most cases, we'll have a template ready for this. So let me show you the template that I'm using. Okay, so this is the template. So the way it works is, this is a template for a lazy segment tree, but we don't really care about the lazy properties over here. All we care about is the point update and a range query. We don't care about the remaining operations, so we can just remove that. We don't need to print the segment tree. We don't care about these functions. We care about our range queries. We don't care. Propagation is a concept which is required for lazy segment trees, which we do not need. build is required. We do not need to have a lazy array. Segment tree does not need to be lazy for this question. Lazy segment trees are used when you need range updates. But over here, at each point in each query, we only change a specific value. So that's called a point update and a range query. Yes. So we can remove propagate also. Yes. So this is the segment tree that we are left with. So let's see what is happening at each portion. So initially, when I make a segment tree for a certain vector, I'm going to find the lowest, the power of 2, which is just larger than my size, because it is very convenient when we have a size that's a power of 2. We are able to build a very clean segment tree. For example, if this were a power of, if this were 5, I build like this, and then so like I have a node here which will represent these two, and then I'll have a node which represents these two, but then that kind of, it does not form a very clean tree structure. So if I then add a few extra nodes to make this a size of 8, then I can have a very clean tree that I can build on top of my array. And basically, if I do not want this to affect my answer, I should just keep all these values as 0, so that they will not contribute to any sum of a range that I'm querying. So this will not affect our answer, but it will make the overall code much easier because we have a very symmetric structure for our tree. So that's why we keep on multiplying n by 2 to find the smallest power of 2, which is greater than or equal to my size. And then for that size, we are going to build a tree on top of it. So the total number of nodes in the tree will be 2 into n minus 1, because at each stage we've got n, then n by 2, and n by 4, so on till 1. So that sums to 2 into n minus 1 when n is a perfect power of 2. And then we start to build it. So basically, our build function will start off at the top of our segment tree. And okay, my build function will be told that, okay, you are index 0 and you keep track of range 0 through 7. 0 to 7. Then it will call its left child and its right child. So when we are representing a tree in the form of a vector, we can store, for if we represent a certain index, if an index represents a node, then its children, its left child. So a perfect binary tree can be stored over here. Its left child, a complete binary tree, its left child will be at index 2 into index plus 1, and its right child will be at 2 into index plus 2. This is if your indexing is 0 based. So basically, we will move on to its left child and tell it an index that its index will be 0 into 2 plus 1, which will be 1, and it will handle the range from 0 to mid. So the midpoint of this will be 0 plus 7 by 2, which will be 3. So this will handle range 0 to 3, and the right child will be 0 into 2 plus 2, which will be 2, and it will handle mid plus 1 to r, which is 7. So like that, this will propagate down, and then the return value will, as we come down, we'll come down to the final node, which represents only one specific value when L equals R. That means it represents only one index in my final array. So if the value of n is within the size, basically if it is one of the elements I passed into my seg tree, I will store that value. And if not, I will just store the default value, because if it's not one of the arrays, if it's not lesser than the size of the array, that means it is one of the extra zeros that I added for a padding to make the structure of my seg tree look good. So in that case, I just store 0, and my default value for an integer will be 0. And then I return this current value. And basically at each point, a parent is built by performing the operation on its left child and on its right child. And the operation by default is plus in this case. So it'll just add the values from the left child and the right child. So it's going to perform that sum that we looked at. For a point update, again, we'll go down a certain path, find the given node that we want to change, and then update only its parents. So basically what we do is, if L equals R, that means I found the node that I wanted to change, I set the new value. And otherwise, if the current index that I want to change, just a moment. Yes, so over here I will traverse down. If the index that I want to update lies within my current node, I will then traverse it further. But if it does not lie in the current node, I will just return the value without changing. So I will not traverse anything extra. I will only traverse down this given path over here. And then finally my query. So as I explained, if the current range is completely within the query range, I return the value of my current thing. But if it lies outside, I will return the default value, which is 0. So that it does not, so any range that does not overlap with my query, if my query is from here and the range is on the outside, I will return 0 so that it does not interfere with my answer. So that is the basic segmentary template. Now let's just use it to solve the question. Let's get the code for the question. Now we need to care about a couple of things, which is, okay, string length s and queries. So first let's get the size of my string. Okay, now let's create the vector, that base vector which we were talking about, with the zeros and the ones. So basically it'll have, let's call it A. So our A will have a 0 if the current index is not equal to the previous index, and it'll have a 1 if it is equal to the previous index. So basically, okay, the first index has no previous element, so it will always be 0. Or either if it's 0 or if it's not equal to the previous element. In this case, our current value will be 0. If not, we push back 1. Now let's build a segment tree on this array. And I showed the segment tree, it just takes a vector by reference of A, based on which I want to build my segment tree. Now let's make my vector for my answer. And basically at the end we will return the answer. So now let's see how do we calculate the answer. So now let's go for each query. So each query is given as a vector. The queries are given as a vector of vector. So each query is a single vector. Let's take it by reference. Query. So my current V will represent the current query over here. So if the first value is 1, that means it's the query of type 1, the flip query. And otherwise it's a query of type 2. So let's see, this will be type 1, type 2 query. So in type 1 queries, I'm given an index j, which will be in vj. And in type 2 queries, I'm given L, which is my left index, which will be v1, and R, which will be v2. This is my range. Okay, so now let's first see how to handle queries of type 1. A query of type 1 means I want to flip in my given string, let's say A, B, A, I want to flip the value of, let's say my index j equals 1. I want to flip this B to an A. So finally, the position over here might change, the value over here might change, and the value over here might change. So we just need to perform 2 updates. So let's first perform the flip. If s of j equals A, then we just, using a normal ternary operator, I'm going to swap it. So basically what this is doing is, if s of j equals A, then if this condition holds true, the first value will be put, and if the condition holds false, then the thing after this, the colon, that's the A, will be put. So basically, if it's equal to A, the new value will be B. If it's not equal to A, the new value will be A. So now let's see, if j is greater than 0, that means there is a previous element. So if there is a previous element, I need to compare and check what update to make. So if there is a previous element, I need to check whether s of j is equal to s of j minus 1. So if it is equal to s of j minus 1, my new value at j should be 0. Sorry, my new value at j should be 1, because that element has to be removed. So that, and elements which need to be removed will be represented by a 1. So I do a point update at the index j, and I set the new value to be 1. And if it's not equal to the previous one, I just perform a point update and I set the value to as 0. And the same thing I can do again. So now if j is lesser than n minus 1, that means there is a position after j. Because if there is a position after, this is our j, if there is a position afterwards, its value also will need to be updated. So if j equals j plus 1, that means j plus 1 needs to be removed. So we set j plus 1 to 1, and otherwise we set j plus 1 to 0. Okay, so that is the way we'll handle query of type 1. Now we need to handle our query of type 2. In our query of type 2, we just need to push back, basically push into our answer vector the result of our query. So if our query, because we care about the range L plus 1 to R. Yes, over here. So for a given query L to R, we want to count the number of ones in the range L plus 1 to R. So basically, if L plus 1, if L equals R, then L plus 1 will actually be greater than R. So there will be no range to query. So in this case, we'll handle separately. So basically, if L equals R, then our answer is basically 0, because that represents a single character. And for that character, and for a single character, our answer will always be 0, because we don't need to remove any elements to make it alternating, because the question states that a substring of length 1 is always alternating. So if L equals R, that represents a substring of length 1. So we just push back 0. Otherwise, we push back to our seg tree, we will query L plus 1 to R. And finally, we just return our answer. So let's see how this works against the samples. Am I missing a expected closing brace at line 126? Let me see. Okay, there's a problem over here. This array, this closes over here. This whole thing has to be moved forward by 1. Yes, now my brackets should match. Oops. Return on should be moved here. Okay, and it's passing on the samples. Now let's submit it. And that passes. Okay, so that covers all the problems from LeetCode Weekly Contest for 180. Thank you for watching.